This is going to be a series of short videos on the control system for dummies. It's not intended for instrument or control guys. It is intended for mechanical, electrical, operators, etc. It is to make people more aware of the control system and give the guys a different way of thinking when troubleshooting. Reset commands to items like the backup overspeed, signals to the balance of plant, signals to station control. This is a fair sample of what type of discrete output circuits to expect. Let's see what information we can get from the drawing. Starting with the information on the control console. The wiring starts from contact 14 on Flex IO AF0060 and it finishes at contact 24, which is the common return wire. The Flex IO is slot 0, which means it is the first Flex IO in the group of Flex IOs on that node. Is to check the Flex IO to see if the status LED is lit. Lit means the output has 24 volts DC. The Flex IO is a microprocessor, which in this example has 8 output channels. These are numbered channel 0 through to channel 7. If a channel is active, its number, in our example 7, will light up. In part 2, we're going to look at analog inputs in the control system. An analog value is one that varies, unlike a discrete value which can only have 2 conditions, on or off, 1 or 0. This is a typical list of analog inputs found in a solar unit. Thermocouples read millivolts to a special temperature Flex IO card. Thermocouples use the potential difference in voltage between the hot junction and the cold. Here we have node AU0080. The easiest way to find it is to look for address 008 on the communications adapter. This is the location of the Flex IO within the node. Each of the 8 channels are listed, with a couple of spare ones. Channel 1 is the level transmitter LT3100. Now that we've found it is important to look at the difference between the thermocouple and the average over time to see if there's a significant change now compared to when the turbine was tested in the test cell. This check is called T5 spread. The signal needs its own special Flex IO to process this signal. To test this circuit, it's straightforward. Although if you have not tested one before, best call on your I&C technician to show you. Set the meter up for frequency reading and take the reading at the Flex IO. Red lead on terminal 3, black lead on terminal 5. The voltage is important, just as the frequency. Typically the voltage will be. Welcome to part 3 of Control System for Dummies, where we're going to look at discrete inputs. Just under half of the PLC loops are discrete inputs and are one of the easiest loops to test. To give you an appreciation of how these inputs are used, let us look at how the PLC uses these inputs in the control system logic. When a compressor set shuts down, it will need to vent the gas that is between the suction and discharge valves. The vent valve will not open until the PLC sees that the suction and discharge valve are fully closed by checking the suction and discharge closed switches. When it trips, it will transfer to the other contact, normally open. This vibration switch is basic and not complex like a vibration sensor of the turbine. It is a mechanical switch that changes state when there is sufficient level of vibration. In our loop oil cooler vibration switch loop, we only use two of the contacts, C and NC. 24 volts will leave terminal 39, which is supplied by the Flex I/O. As long as the switch is closed. Welcome to part 4 of Control System for Dummies. This is the final video in the series. Analog outputs are signals to control fuel valves, PEC actuators, surge control valves, VFD speed commands, etc. The logic calculates what output is needed and when it is needed. So that this is channel 0, channel 1, channel 2 and channel 3. In this example, the milliamp signal leaves terminal 8 and flows through the actuator instrument and returns back to terminal 9. It is the logic that controls how many milliamps will flow in the loop. The terminal base seems to have many connections, but the same base can be used for many different wiring options and different flex. Once you are all set up, you will be able to stroke the actuator to any position you want, or to control the speed of the VFD output to the motor. Note that the VFD or PEC valve normally have a run signal that has to be energized. In summary, having the knowledge that you now have, you're in a better position to resolve problems. If you get the opportunity to use a multimeter on your plant, use it regularly so that you familiarize yourself with how to use it correctly. Practice will improve your knowledge of the drawings, wire locations, etc. It will also give you confidence when taking readings with your multimeter. And finally, never be afraid to ask for help. We all have to learn at some stage.